We stopped at just a moment because there's no source and all that. So, hi, it's newer logs, right? Automated cluster snapshot, incident. So this is my previous video, anyways. So we actually stopped at the whole fault tolerance, testing of fault tolerance, and the next one is observe and identify SQL performance issues. But before we go there, I wanted to show that the notifications for the failover came up. So this is a message to notify that RDS will attempt to send you event notifications of type DB cluster to the topic this, right? So please do not reply directly to this email. If you have any questions or comments regarding this email, please contact us at the support. Event source DB cluster, source ID. So it's a database cluster. It's not just a database, it's the cluster, and the source ID is Aurora MySQL cluster. Notification time, this is UTC time. They didn't put the time zone weirdly, but it's okay. Started cross AZ failover, and then completed, and then again started AZ failover, all that, and then completed. So and then this one was again started, I think, right? Interesting how it puts this and is completed, and then again this one was started, and the notification time is different, but the message was the same, so it just kept putting it inside this expanded content, trimmed content. So you can actually see how it started and completed again and again, and they are giving the event ID also, so you can actually go and see it. So the event ID actually keeps changing. So this is 73, 71. Okay, so I think event ID is just to say what kind of event it is. So I guess if you open this up, you'll probably notice that 0073 is basically this, right? It's a failover. So and 71 is basically completed, right? So this is completed failover, right? So there are a lot of events, DB cluster events. So we can actually see all the events over here, right? And then yeah, a lot of started, completed, started, completed, started, completed. I did a lot of it. Started, completed, and then again started, completed. This one was again started and then finally completed. So there were like I think some 15 notifications. So you can actually see 14 of them for these started and completed. Basically, I think I did it 7 times. So yeah. So you can actually see this is the first one. This is just to say that you'll get notifications. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 of them, so 7 times basically. Started and completed 2 times, totally 14 times. Cool. So now let's get started and look at the next section, which is observe and identify SQL performance issues. So this lab will demonstrate how you can use native AWS tools as well as community tools to achieve observability. So we'll use community tools and AWS tools to achieve observability of your Amazon Aurora database clusters. Cool. You will run a sample workload on your database cluster and review monitoring and logging data to analyze the performance of the database and its workload. So I don't know what it means when you say performance of the workload, because workload is just a query that you run, the data that you have and all that. So anyways, So this lab contains the following tasks. So prepare the initial dataset, verify the slow query log is configured correctly. So run a sample workload, monitor database performance using Amazon CloudWatch metrics, monitor database performance using Amazon RDS enhanced monitoring, dive deeper with database insights, and then leverage Amazon CloudWatch logs and log insights to view and analyze slow queries. Test, I don't know what that is. Download slow query logs, monitor database metrics using performance insights, which is optional, and then this lab requires the following lab modules. Yep. So let's go ahead. Just a moment. Okay. So prepare the initial dataset. So let's connect to the database. I think I'll be using, so this MySQL query, I have it already. So MySQL -h, it's this one. This is the backtrack process, so I'll just leave it. So we have two of these here. So this is the cluster, so let me run it. Okay, so we have it here. Let's make it bigger maybe this time. It's been very small. So once connected to the database, please use the code below to create the schema and stored procedure needed later in the lab to generate load on the DB cluster. Run the following queries, SQL queries. So we'll be creating a weather table, I think. So drop the table if it exists, which is the weather table, and then date string. So it's a date and not null comment, or you can add comments, interesting. Date and time of readings, and then degrees. Okay, one E is missing, and it's from mean. Okay, from mean, and then ID, longitude, decimal, latitude, decimal, max temperature, minimum temperature, station name, and then weather station name, I guess, and then the type, and then serial ID, and then engine is InnoDB, default, character set Latin, and all that. Create procedure, declare key value 1, key value 2, int, I think it's an integer. So just a moment. Set key value floor of this random, I don't know what this means. So date string, I don't know, degrees from mean, varchar, I don't know. And then ID, longitude, okay, not null, default is null. Okay, so I think we are giving default, is it? I don't know. ID, comment, station ID. Is this the latitude, longitude, and latitude? I don't know. ID, is it this? I don't know. And then the max temperature, min temperature. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Are there 9? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Anyways, I don't know why we inserted and then deleted also. Interesting. So this is serial ID, this is the type, this is the station name. This must be the min temperature and max temperature. Latitude, longitude. This must be the ID. And this must be the date string. So this must be null then. I don't know why they deleted it. Just a moment. Okay, so next, load an initial dataset by importing the data from an Amazon S3 bucket. Okay. First of all, I don't know what this does. Like procedure, begin. Okay. Insert into table, character set, fields terminated by, optionally enclosed by, ignore lines 1. Okay. Delimiter, and then finally load dataset. So anomalies.csv, I don't know if we have that here. I think we might have it here. Do we? Anomalies, no. Anyways, I'm actually gonna ensure that, okay, Oops, let me close. Yeah, I'm just gonna enter and I'm actually gonna get this data maybe. Let's download this. How do I? How do I get this is the question. Well, we can get it later. For now, I'm just gonna. So let this run. Data loading may take several minutes. You will receive a successful query message. So that's around 319.6832.0246. Okay, that's like 3.1 million rows, I think. That's a lot of rows. Okay, so it has done. It has done running. It's done running. So it has finished processing. So let me just remove this off. And let me just put this here. It's supposed to be this. Okay, so we have this here, and let me go ahead and let me see if I can actually find load data somewhere else also. No, interesting. Load data, nope. I think I remember seeing load data in other places. I'll find it out. So for now, I can actually just get this URL for now. So I should have gotten all the commands that I ran. Anyways, I will try to get it, but for now, this is MySQL, and I can just say SQL. Yeah. So yep, and SQL. Yep. Cool. So now I'll just go to the next one. So verify the slow query log is configured correctly. In many cases, the slow query log can be used to find queries that take a long time to execute and are therefore candidates for optimization. Okay. So in many cases, slow query logs are controlled by various parameters, and the most notable ones are slow query log, long query time, log output. Okay. So these are MySQL documentation references. Let's get it here, and we can look at it. Services. Okay. So changing slow query log settings in production. In production systems, you can change the values for long query time in multiple iterations. Example 10 to 5, and then 5 to 3, and so on, to find the best value that fits your workload's needs. Okay. So please make sure your output matches the example above. Slow query log is equal to 1, long query time is greater than 0, and log output is file. If your values do not match the configuration above and you're participating in an organized event, please reach out to an assistant. Okay, when completed, just quit. So quit from the MySQL command, that is. There are other useful parameters controlling what statements get captured by the slow query logs. This is log queries, not using indexes, and slow admin statements. Okay, interesting. I think these we can actually look at it. So now, one moment, just a moment. I need to just do something. One moment. Okay. Cool. I think I'm just gonna close this up. Part 7, part 8, part 6. Okay. I actually have some of these recorded stuff that I'm trying to upload. Cool. So now, just a minute. Scheduled for July 15. Okay. So now I'm gonna actually run this thing, right? On this, and run this. Right, so you get one file. Awesome. So we can quit now, I think. I'll just say quit. It says bye. So now I can run the Python thing, weather performance, which I believe I have locally. So if I do this and so AWS workshop weather perf. So this is the thing I think they're going to be running. So let's look at that. Sample workload. So this is what they're going to be running. So this is the weather perf thing. I can probably put it here. Put it here maybe. Weather perf sample workload.py. Okay. So what does it do? So arc parse, endpoint, password, username, database, threads, analytics. So Yuma, Sandberg, Mozilla, types, station ID. Okay. Thread function, progress function, track analytics, start new thread, progress function, thread ID in range, rs.threads. What is thread ID? Okay. Global query count, log, start time, initial is not equal to true. So initial is equal to false. True, end time, queries per second, I guess, format query count, and then here, and then this is the progress, and then thread function, and then you iterate iterations. So start new thread function asks query iterations 50. Okay, so that is the values. So 50, so 0, 1 to 50, I think generate a random number to use as the lookup value. So random range, key value, key offset, okay. Query type is equal to 0. So select no SQL, no cache, okay. This is the select statement, call insert temp, call minute rollup, I don't know what that is. Point query with hashing, okay. Point query with hashing, stored procedure, range query, point query, okay. Okay, point query, range query. So this is where, no, with hashing, where ID is equal to this. Stored procedure, range query, where station name and type is equal to, okay. Aggregation, so you have probably count, okay. Square root, range query, okay. Point query with hashing, okay. So looks like it's running something specific. Oops, I put an X here. Cool. So we should probably mark this as read only. Can you do that? Anyways, I'll close this up now, and we can actually run this now. Let's go ahead and run this. Let me change the cluster endpoint to MySQL -h. This is the cluster endpoint. Okay. Cool. So let me run this, and It is, oh, I think there's a problem. One moment. Sorry, I copied the wrong thing. Yeah. So it's happening. Now it's showing me queries per second and all that, and it's showing what it's executing and all that. Proxies, we don't have any. We can get rid of this. Event list. Cluster snapshot created. Okay. Cool. So we'll keep these up available. So run a sample workload. The script will take about 4 to 5 minutes to complete, but you do not need to wait to proceed further. Okay. So let's just go. Coming. Yeah, coming. Yeah, coming. Okay, looks like I need to go, but I'm actually gonna let this run, and in the meanwhile probably stop this, and I'll continue again in some time. Bye bye, folks.